I'm trying to get this where it can see me instead of we're gonna have to fight with this a bit. But anyway, just share it. Okay, there, that's what I want. I'll learn how to do this. Okay, screen one. Nuts. Somehow I'm not coming through, but the one in the middle is the National Electrical Code Handbook. If the code book is 1 inch thick, the handbook's going to be 2 inches thick. And by the way, the paper is usually onion skin just to keep it down to 2 inches. What that is, it has the entire National Electrical Code, but it also has commentary. When the code says this, what does it mean? That's what we're talking about there. What'd you say, House? Unmute and make your statement, please.
Yeah, I did that wrong. It didn't have my name on it. My name is Don Taylor. I live in Kansas in the county. I am a licensed PE, and the county has never adopted any of the uniform building codes.
Well, this is not uniform building code.
Well, no, but as
is National Fire Protection Association, book number 70.
I'm very familiar with the NEC. I worked for 38 years for the largest utility in Kansas. But it's a case of they haven't adopted anything. And so there's one issue in the county, and it's kind of, if you have a septic system, where does the effluent go?
Well, that yes, okay, and that does
this is Kansas, so
yes, but that does lead to another statement that will follow this one. But if you don't know about the code, you can go to the handbook for help. If that is not helping you, you really need to take a basic electrician's class at the local community college. And that means you're going to have to be an electrician. Now, this goes to what, Bill, you said your name was, right? House?
Yeah, I said my name was Don Taylor. I'm a licensed PE in Kansas.
Yes.
I live
okay. I just missed your name. Yes, I missed your name. But here's the thing. Thank you, Don. As Don was saying, he's one in the county. Even in Texas, we have that problem. There's a state law that says all work shall be done by a licensed contractor, but there's absolutely no one to enforce it. So even if you call the Texas Department of Licensing and Regulation to complain that someone had wired a house and done a lousy job, there's no one to take your complaint. TDLR says we can't help you. The next question, though, is who is your utility? In the city of Austin, there used to be design criteria. It was more stringent than the National Electrical Code. Little things like, for example, the sorry, the question threw me off. National Electrical Code, the minimum size conductor in Austin used to be number 12 AWG, even on 15 amp circuits. So that exceeded the code, but since we adopted the state licensing law, that's really kind of taken that out. First thing I want to get into is receptacle installation. Shall be such space such that, move Ty's picture so I can see. Receptacles shall be installed such that no point measure horizontally along the floor line of the wall space and more than 6 feet from a receptacle outlet. That is important, but let's see what we're talking about. Come on. Yeah, for some reason I'm not getting this thing to switch when it's lagging on me.
Okay, got it.
Control A. Here's a house layout. No, it's not mine. My house, this is 51 feet deep from the front to the back. and my house is only 30 by 30. It's this one master bedroom suite is about 1/4 of my house, to be honest with you. Let's look at that in detail instead of the whole house. I've redrawn the what we had in that segment. And the question is, where do the receptacles go? Well, first off, don't worry about the hallway right here. That there's different covering on that. This area behind the door, we can, come on you, let go. We can exclude that because it's behind the swing of the door. Now, start the arrow right here and just as a place to measure. We could start it on the other side also, but we'll start right there. Measure 6 feet, put a receptacle. Measure 12 feet to the next receptacle because receptacles are not 6 feet apart. No point on the wall measured horizontally shall be more than 6 feet from a receptacle. 12 to the next one. So, how do I move that stupid? Is this thing blocking your view like it is mine? There. Okay, there's the receptacle behind the, kind of behind the door. It's up to your local inspector to tell you what is accepted and what isn't. Oh, and by the way, you're going to need one over here. This will just about fit center of the wall. Most electricians, when they come in to wire your house, they say, we wire according to the National Electrical Code. We meet the code. Well, that's very nice, except for one thing. The code is the minimum. And anyone who wires to the code says, I'm going to do as cheap a job as possible. Now, what was that, Bill? You had the same problem? Yeah.
I can talk then, huh? Yeah, I'm getting the same problem I got on another meeting I was at. Couldn't get rid of the crap at the bottom.
Yeah. Well, here's what you do. That is your minimum. However, what you can do, oh, by the way, we need an outside receptacle for this porch over here. I forgot about that. Let's start over here. Same measuring place, but where do you want one? Right here. Because it's close to the hallway, it's close to the room. You're not likely to put furniture covering it right there. One of the things I looked at when I rewired my house was, where was I likely to put the bed? Where was I likely to put head tables at the bed? Where was I likely to have dressers? The next thing is, and that's just about 7 feet away, is another receptacle on this side of the wall. Because if you put a dresser right here, that you've got access to that receptacle, but you've also got room to put a dresser or something, or even your bed right here, and you've got access to the receptacles. Now, just in case you put the dresser on this wall and leave the window available, you want a receptacle there. And then, Bill, what are you saying about the symbols? What did you say about the symbols, Bill? Okay. Anyway, put another one under this window. How about one in the middle? You could. And then this, again, same thing down here. Where are you going to put a dresser? Where are you going to put your bed? What if you put your bed right here in the middle? The way we had it in the previous slide, receptacles right there where you can't get to it. And then one here. Oh, and by the way, probably two on this wall because you don't have to have that one. But if you're going to vacuum in here, that's an easy place to get to it. Outside, well, yes, you want one here. What about one over here? The thing is, the code specifies a minimum. You can exceed it. I highly recommend, even if you're going to have an electrician do your house, you figure out where you want those receptacles. And don't wait for him to try to get it for you. Yes, as a professor used to say about steel, he said, steel's like butter, you buy it by the pound. Well, receptacles are like cabbages, you buy them by the each. So you're going to have to pay for this. I rewired my own house. I could afford to put these in all sorts of places. But it is something very serious to think of. How many of you checked into a hotel and guess what? The receptacles are all buried behind the dresser and behind the headboard of the bed. You can't get to them. Yeah, nice hotel. Just to show you, this is my living room. It's a composite picture, so please don't get vertigo looking at it. But I backed up as far as I could just to get these photos. The living room is 13.5 by 17, so that's 17 this way, 13.5 along the far wall there. Right here underneath this coat where you can barely see it is a receptacle, and these arrows hit backwards of what I wanted. There is one underneath this window. There's another one right here. On the other side of the fake fireplace, there's one right here. And by the way, on this wall that's behind us here and beside, there are a total of 2 receptacles in each wall for 4 receptacles. Because it depends on where I put the bookcases and the couch as to what gets blocked. Yes, I loaded it. But by the way, I can't get to that one, but this lamp has the place to plug in. I can get to this one, and that's where I plug in my cell phone for vacuuming and other things convenient. That's the main receptacle to use. It's nice to not to have to fight to get to the receptacle. It's right there. That's what I'm thinking about. How high above the floor, that's a consideration on your part. I put them where I liked them. The bedroom, this is just turning your back on the previous photo. Just turn your back, and here is the bedroom. And again, where are the receptacles? That makes them really along this entire place about 6 feet apart. But the thing is, again, this one's blocked, but I've got things like the electric blanket. There you can see the cord plugged in there. Oh, blanket's not plugged in, but it's there for winter. This one's easy to get to. This one's sometimes blocked. This one is right beside the door frame, just like the one I showed you at the entrance of the house. The wife's lamp is plugged into what? A receptacle right back here, and one here in case I need it. They're there. That's the big thing. Where do you want them? That's what you need to consider. Wiring methods. Let's see. I'm going to check real quick. Oh, no. I'm going to go back to, let's see. Can I find my slideshow? I think that's it. Yeah. And I want to get chat. I've got messages. Yeah. For the video. Okay. Height above the floor is another consideration that Don wrote. Yes. And the question is, how high do you want them? Not down in the floor. That's no longer legal. And it's also a very bad idea. Wiring methods. Romex is the most common. This is number 12 too, that you'll see. Then the next thing is armor cable or BX. Come on, you. Metal sheath cable. There are some places where this is preferred if you're going to go outside. There are inside and outside versions. This happens to be an outside version. That's okay. You can string this also. If you're going to do it yourself and you have stripped the walls where you can get to them very easily, stripped all the drywall and you want to start all over, or else you're building a new house, I recommend EMT. Now, this tubing does require a bender, and I'll show you in a moment, but notice you're not restricted. Over here in these, the first two, you either get 12-2, which is black, white, and a ground, or you get 12-3. This down below is 12-3 armored cable because it has red, black, white, and a ground. In EMT, you get to pull anything you want. And by the way, you do not need to pull a grounding conductor in the EMT because it is the grounding conductor. A bolt current or a fault will not see that little bitty flimsy number 12 when it's got this entire 7/8 inch diameter conduit to look at as a conductor. You can if you feel safer pulling the ground, but you don't have to. That's my point. With and then the other thing is flexible metal conduit. Sometimes rather than try to bend the EMT or snake it up to a wall, it's easier to use flex. And again, unlike armor cable, flex is empty. You pull in the conductors you want. Let's see. Now, this is where I wanted to take this off of here. Stop sharing for a moment. And the camera should be on me.
Yes.
Kai, everyone should see me on the screen. Are they?
Yeah.
Y'all seeing me? Or you seeing Kai?
Yeah. I see you.
We see you.
We see you.
As long as I'm the major picture on the screen, because what I want to show you and I haven't looked at little bitty screens that makes it harder. Here is your electrical metallic tubing. Someone had already bent a bit of an offset in it. Let's say I decide I need more. This is your bender. You can buy them from Home Depot or an electrical supply house. Put that one right about where it was there. Line it up. I've just now increased the offset. By the way, you can bend a 90-degree bend, which normally you'd put this on the floor and bend it up. And there you have a 90-degree bend. Not quite, but we're getting close. I started with a crooked piece. That's important. But simple tool, just takes a little bit of paying attention, a little bit of directions with it. By the way, you can wire an entire house. How do I know that? This house is wired using see, I want to go back to sharing,
Okay.
and that's, let me find it. Let's see if I clicked on the wrong thing there for a moment. Share content there. Okay,
Got it.
so my entire house was wired using EMT and Romex. By the way, later after putting in the ceiling lights, I decided I wanted to put in ceiling fans. No problem. Had to cut an extra switch into the wall, but then I just simply ran an extra conductor. So, and now I've got a hot to the fan, and my lights are still switched. I don't have the fan, the light switch controlling the fan. Turn off the light to turn off the fan. Nope, I don't. Okay, Joe, you need to mute yourself. Thank you. What type of connectors? You can get different connectors at Home Depot and Lowe's. What I recommend are these by 3M. No, 3M did not pay me to do this. You can only get these at an electrical supply house. Walk in, buy them. But these are the the ones you'll see mostly nowadays. These two are the most common. The red yellows, the tan yellow and the red blue are used for the very small, like a wire, the fixture leads. The ones you'll need for number 12 and number 14 are these two. They are the same range. It's just that this one's a little bit shorter when you're in tight space. The big blue and tan or blue and gray, you might need a few of those, but mostly you won't. You should be able to get it with these. And these will take something like 5 number 12s. The only thing I recommend is if you're mixing stranded and solid wire, make sure you twist them good with your pliers before you put them on, because the stranded wires will tend to sneak out on you. These two side ones I'm not that familiar with. I've seen them, but they look like the Buchanans and some of the others that I'm not fans of. These are the original 3M Scotch locks, the red, the yellow, and the gray. Again, you should not need big blues. I seldom ever used them. These two, as far as I'm concerned, are the cat's meow. Once you twisted those on, wires didn't come out and they didn't come off. So these, not quite permanent, but they were made for motor vibration where they wouldn't back off. The ones you can get easily today are these, but again, you will not get them at Home Depot or Lowe's. You will have to go to an electrical supply house. And then, yeah, these are the close-up of the ones I was showing you, the original Scotch locks. By the way, if you have a house with aluminum wiring in it, you don't want to rewire the entire house, but you do want to change to copper pigtails. The only ones that are UL listed for that conversion are these Scotch locks right here, not the red, yellow, and the red tans, but the yellow and the red, white, and blue Scotch locks. What you do is put a little bit of antioxidation compound in each one, and then screw this down on your aluminum copper connection, and you'll be safe. Now, here is Romex. This is very typical. And by the way, you run down a feed to a box, and then you've got to run your switch leg up, and then you've got to run somewhere else. And each time you have to run an entire Romex. You only need one conductor, but nope, sorry, you got to run all 3 of them because they come in 3s. By comparison, this is an EMT job. He's hitting a bunch of different switches, receptacles here. And by the way, he only has 3 conduits. One of those is probably superfluous, but he just decided to bypass that box. Maybe he cut it in later, put it in. Nevertheless, change his mind on the wiring. You pull out the wires, you pull in new. Our church was recently, a new church was built, and I found out the electrician was contracted to use armored cable instead of EMT. And all I thought was, gee, thanks for the committee that made that decision. They're not the one that has to do the maintenance work on that. It'll be me. And now they've made it that I can't change things and correct them without breaking holes in the wall. Here's another EMT installation, especially out in the garage. It really, really is nice. There is something besides EMT, and that is wire mold. Here's a couple of installations. It is surface mount. It is good looking. It is safe. It is UL listed. You can get them plastic or metal. Personally, I'm a big fan of plastic. However, in wire mold, you do want to pull a grounding conductor because you can't be sure of the connection between the boxes. So pull a grounding conductor. Here is an installation. What you see on this cover plate is where the original receptacle was in the bathroom. Only for the entire sink counter, that was the one receptacle. And my sister complained that she needed more receptacles. Well, I put a total of 3 in there. Yes, it's the same circuit. Yes, it only accepts the same load. However, instead of fighting everything to right there, she now has, here's a longer view of it, 1, 2, 3. And that's because I convinced her she didn't need a receptacle there anymore. The loading is the same, but now they're convenient. And you can, the reason we showed these pictures, that shows you what it looks like installed. That shows you what it looks like when that house is actually in use. Wire mold is not bad looking. By the way, the coloring on it is suitable for painting. It's a prime coat, so yes, it is suitable for painting. So again, like EMT, you can pull the conductors you want. And you notice that all three of these, well, you can't see it there, but trust me, all three of these receptacles are GFCIs. Well, wait a minute. How do you, don't worry. I will get to GFCIs in a moment. In fact, right now. Notice there's two different face plates here. It doesn't matter whether they're GFCI or regular receptacle. The difference between these two is this is a 15 amp receptacle on your left. This is a 20 amp receptacle on your right. Now, how often will you need a 20 amp receptacle? As far as I'm concerned, you can unmute yourselves and shout out answers.
No.
What was that, Ruth? Trying to get Ruth's.
It depends on the power tool I'm using.
TR and WR on the right. Oh, that's just, I see what you're talking about up here, TR, WR. Actually, this, see that little sideways key? That's your clue that this, and it's not there. This is a 20 amp receptacle. This is a 15 amp because it's just a straight. And something you need to know, wide is white. The longer of these two pins is the white wire. The other one is the colored wire. And by the way, that's American wiring, not European. In Europe, they believe that all colored wires are hot. Any wire with no color is the neutral. So guess what color the neutral is, folks? It's black. White wire is a current carrying conductor. Wait a minute. Wait. What's the matter with you people? Oh, Mr. Mercer, you do not understand. You see, white is all colors together, whereas black is an absence of color. Therefore, black is neutral, white is a current carrying conductor. But not in the United States. White is considered no color, and white and natural gray are the neutrals. All other colors except green are considered current carrying conductors or HOTs. But how often do you need a 20 amp receptacle? To be honest with you, you don't. The NEC says if you have a single receptacle on the circuit, it shall be a 20 amp receptacle. And then we find out this is not a single receptacle. This is a duplex receptacle. Therefore, we only need a 15 amp receptacle. When you've got just the little circle and that's all it has is one place to plug in and nothing else, that's a single receptacle. That has to be a 20 amp if it's the only receptacle in the entire circuit. But if it's a single duplex, 15 amp, even on a 20 amp circuit, yes, that's true. And you save a little bit of money. Go with it. So, how do GFCIs work? Well, first off, it works like a balance scale. Voltage is not a factor in this. It is strictly the amperage. It is looking for a differential between the white and the current carrying conductor. And by the way, it doesn't matter if you overload. Do not depend on GFCI to protect your circuit from an overload. It won't work because you can load the scale equally on both sides until you break the arm, and it will still say. Now, what it is looking for is an imbalance, and it's looking for specifically about 5 milliamps, between 4 and 5 milliamps. As soon as it gets to that imbalance, it trips. And it doesn't matter whether it has more current on the white than on the colored or vice versa. All it's looking for is an imbalance, and that's when it trips. Now, here is one of the questions that Kai, I think, was alluding to when he sent me his questions, and that was, how do you get so many GFCIs and they don't work, and what's going on? Well, here's usually what happens. Let's take this area. We need a receptacle here in the bathroom. By the way, if we want to be really nice, folks, we'll put one there also. We should have one here in the laundry room. Now, the washer and dryer, if they're gas dryer, electric washer, have their own receptacle, or even one each, whatever. But you need this for other convenience. Out here in the garage, you need at least one receptacle. Could be on any wall, but this way the car doesn't get in the way. And usually it doesn't hurt to have one outside. You're going to have an outside one. At this end of the house, we have these 5 receptacles. And now the panel is somewhere over here. So the electrician's going to wire them. What's he going to do? One of these is going to, there they all, they're all wired on one string. And then I think I'm missing something right there because, yeah, this one should have been first. This one's a GFCI. And now all these others are not GFCI receptacles. The code says it shall be GFCI protected. It can be through the circuit breaker or it can be through a receptacle. And by the way, this GFCI could be on the outside, and then the line will go here and up to here and so on. So if there's any problem anywhere, this is going to trip and you're going to lose all of these receptacles. Is there a way around it? Yes. What you do is you replace each and every one of those with GFCIs. So now each one is on its own, or should be. But let me show you what usually goes wrong when we do that. This is the backside of a GFCI receptacle. And I think I got these out of order. Yeah. Save that real quick. And now we will go back to the slideshow, our regularly scheduled. Yes, Don, we'll get the AFCIs later. This is the backside of 2 different GFCI receptacles. Notice that this says line and this has yellow tape over it. Sorry about the blur. I didn't take that photo. You know these are facing the same way because the grounding conductor is on the bottom of both of them. Notice this one says load and this one says line. Don't simply swap out a GFCI receptacle. You've got to make sure that the incoming power comes into the line. Yes, this does make a difference. A neighbor did that. He pulled out one. He marked his conductors. He put the new one in. He says, James, I got power. I can see the little lights on, but the receptacle's not working. Well, it turned out he put the 2 line conductors here and the 2 load conductors here. And that's why she doesn't work. So you got to turn the receptacle over, look at it and see which side's the line and which side's the load. Look at the old one before you pull it out and make sure you mark the line conductors and the load conductors. Now, going to this one, here's the line side. And here are 2 regular receptacles. Designer type, but that's okay. To protect these, what we do, we have the power coming in. And then and on these screws, on the regular receptacle, they're electrically the same. On each side, 2 screws are electrically the same. So doesn't matter whether we hit top or bottom, they're the same. GFCIs are different. This way, if there's any problem here, it will trip this GFCI, and these are protected. You've met the code. So then we have someone decide, well, you know, we need to go back to the right here. Yeah, remember we said we wanted to change these to all GFCIs. Okay.
Oh.
Do we have a problem?
Oh, yes.
Yes. A problem on this one could trip this one or all 3 of them. A problem on this one will knock out all 3. A problem on this one will at least knock out that one and could possibly trip this one. Okay, now we got some nonsense. What's the solution? Very simple. Look at where we're putting them. Line to line to line. Now the upper and lower holes on the line side, those are electrically the same. Now, any one of these can have a problem within itself or what's plugged into it, but it's not going to take everything out. Only what's plugged into it. Any questions on that? Are everybody happy? Okay. Arc fault interrupters. Don wrote, required in bedrooms. Well, yes, Don, in the old days. Something like 2008 NEC, it said all circuits, whether lighting or receptacle, didn't matter. If it goes into the bedroom, you shall have arc fault interrupter circuit breakers. And now the code says, has a whole list of where it's required in new construction. Let me read that real quick. You'll love this. Let's see, 21012, if I can find it fast enough. If I can find the little tiny numbers. Dwelling units. All 120 volt single phase 15 and 20 ampere branch circuits supplying outlets or devices installed in dwelling unit kitchens, family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, laundry areas, or similar rooms or areas shall be protected by one of the means described. In other words, arc fault. And by the way, when you get through reading all of that, pick out some place that's not required to be protected by arc fault. Yeah, where is arc fault what not required? Yeah, Ruth, that's the point. If it's a 120 volt circuit, yeah, 15 or 20 amp, you're supposed to have arc fault. And there are different types. These are, I tried to get these pictures. Yeah, Ruth adds, might as well, oh, garage. Alan wrote, you don't need them in the garage. Well, he's got a point there. And Ruth says you might as well use them everywhere. Therefore, you're not getting mixed up. Yes, there's Eaton Bryant or CHB. Eaton has bought out Cutler Hammer, but that was Cutler Hammer Bryant. There's Genuine Cutler Hammer, Genuine Square D, Square D Homeline, and GE. If anyone here is from GE, I'm sorry, folks, but when it comes to the branch breakers, I have favorites among these, and I'll tell you what they are. Genuine Square D, Genuine Cutler Hammer. These two look skinnier, and they are, because these three, the CH Bryant, Square D Homeline and the GE are all 1-inch platforms, as they call them. And these two are 5/8 inch. And you say, well, gee, bigger is better. Actually, no. The two 5/8 inch platforms are excellent. What happened was Square D was too expensive to go into homes and they were losing money. So they bought out Murray, and that's when they became Square D Homeline. Cutler Hammer didn't want to get left off, so they bought out Bryant, and that's why you got Cutler Hammer Bryant. So no. I've dealt with those. I'm not. They work. Now, if you're talking about Federal Pacific, I'm going to say straight up, and you can quote me on this. If you have Federal Pacific in your house, you have trash. If those circuit breakers are more than 5 years old, you're not sure whether it's on or off. Hell, it's not sure whether it's on or off. So replacing a panel with that has Cutler Hammer breakers is well worth your money and safety. And by the way, if you're going to do it, personally, I would do this. Now, let me tell you about the breakers. We got good news and bad news. They work. Unlike the ground fault circuit breakers and the ground fault receptacles that used to trip because, gee, it's a little foggy out today and there's some humidity in the air. When I was started in the construction trades in 1974, there were mornings we could not get started for at least 30 minutes to an hour until enough body heat in the area drove away the fog, especially along the Ohio River, because the humidity itself was causing the breakers and the GFCI receptacles to trip. Yeah, they have improved. They are much better now. I used to help people cheat. Okay, put in a new panel, put in the GFCI circuit breakers required. Okay, as soon as the inspector's gone, replace them with regular ones, and then you're fine. Arc faults work. And there are some stories about them. Brand new construction. Thomas Dimitrovich was telling that somebody he knew had a new house, and he had one circuit that kept tripping, and the electrician came out and said, well, probably that good old West Virginia boy, because this is where it happened. Probably that arc fault breaker. You know, it was kind of funny. So he swapped out and put a regular breaker. Well, then it started breaking, not as often as the arc fault, but it wasn't staying on all the time. So this guy got smart and he called a different electrician who came out, put a brand new arc fault breaker in, and first thing it did was trip. And he said, okay, now we're going to find out why. He traced it down and up in the attic where the joist, framing members of the joist, there's a metal mesh that the carpenters put to hold those boards together better, especially when they fit this way. It's a structural thing. The electrician had drilled through that metal mesh, and the Romex was sitting there on the metal and rubbing and was arcing. That's the sort of stuff that burns houses down. Arc fault breakers work. And you're saying, well, James, with this good news, how can there be any bad news? They cost. These two right here, you're looking at $50 each. Now, the CHBs, the Homeline, and the GEs range from $30 to or $35 to $40, so they're a little bit cheaper. But the two genuines, $50 each. And if you get a combination breaker, they're $55. And I'll explain that in a moment. I was thinking, these are so great. You know what? My children in their houses, I got 3 sons. You know what? I should, for a present to them, I should replace their breakers with arc fault breakers. And then I found out what they cost. If you've got an average of 20 circuit breakers per house and you replace them. Now, these as regular breakers, these let's see, the three off ones cost about $5 each. These two cost you about $7 each. So 20, that's $140. If you're talking about 20 of these, we're talking $1,000. I love my kids, but do I love them $1,000 worth? Let me think about that. Okay, I do. I just can't afford it. So that is a consideration. If you're building new construction, you have no choice. If you're rewiring the house and pulling a permit, you are going to have to, your permit will not be approved unless you put in GFCIs. If you're going to do a service upgrade or a service change, you're going to have to replace all the breakers with GFCIs. Normally, because the inspectors normally demand that. It's the only way they can bring things up to code. So just know that going in. And by the way, that brings in the subject about the rest of the house. Yes, your inspector can demand, if you're just extending a circuit, you're putting in one receptacle, that's one thing. If you are putting in a change in the service panel or making any sort of major upgrade, he can demand the entire house be brought up to code.
Wow.
Yes. Oh, and by the way, while they're at it, they can also demand that the plumbing code be brought up and the access code. So do you have doors wide enough for wheelchairs, things like that? Yes, they can. They love to do it. Now, types of circuit breakers, series and parallel. What do? You see that? And by the way, I did not price dual function breakers. Now, somebody asked me, well, James, what about AFCI receptacle? Well, that's nice, but the only thing it's protecting is what's plugged into it. So the series thing is where you've got a cord plugged in, that's usually where you have a break in the cord and your arcing is in that extent. There, camera right there. Sorry, I was looking at you and it's there. Okay, that's where you get the break in the cord. The parallel is when someone drives a nail and you get that arcing across the hot and the neutral. But if you have an AFCI receptacle, oh, and by the way, the one I looked at, it costs something like $35. Maybe it's only 30. For that much money, go ahead and put in the breaker. Be done. Be safe. Take care of it. I could ask my sons to pay, but the only thing is I'm really supposed to be taking care of my son. So how much for a new panel full of breakers? No. It's if you get an account with the supply house, if you've got well, gee, you know somebody, another electric, okay, they're big customers of ours, I'm going to give you their discount. That's the only way you're going to get a break. And whether you buy one or buy a whole panel full, sometimes they feel sorry for you and they say, tell you what, okay, I just made it look like you bought this cash, but you actually worked for that electrical contract over there. So instead of $1,000, it's going to cost you $800. Hey, we saved you money. I'm sorry, but that's the way it goes. So, final about rewiring your house. Can you? I don't know. Can you? May you? Yes, you may. We covered that. Should you? Okay, now we get into a bunch of things to discuss. Do you have the technical know-how? Are you familiar with the electrical trade? Or can you learn enough just to know how to do some things? Do you have the construction know-how? I'd say the electrical trade. You are mostly here electrical engineers. You probably have the technical know-how. Let's put it that way. That's what I meant by that. The construction know-how. That's a little bit different. How do we get a hole there? How do we get into this corner? How do we do this without destroying a wall? That's your construction know-how. Is it okay to drill through this? Oh God, no, not that one. That's a critical beam. Do you have the tools? I was going to bring my tool pouch in and show you, but the poor thing's about as big as a big noodle pot, and it's stuffed with screwdrivers. You can get away with about 4 of them. You need a stripper, screwdriver, 2 different screwdrivers, and a set of lineman pliers. So that you should be able to get for $100, about $100 worth. Do you have the time? Folks, I'm not joking. Electrician shows up at the job at 7 in the morning. He takes a 30-minute lunch, and then he leaves at 3 o'clock in the afternoon. 8 and 7, 15, no, 3:30 in the afternoon. You have just put in a full day of work, and you've driven home, and then you get supper. And then, now the electrician goes home, and he sits down, eats supper, and he sits down in front of the television or whatever else. I'm going to make fun of them, being an electrician myself. Sits down in front of the television, watches television for a couple of hours, has a couple of beers, and goes to bed. You have been in the office all day. You go home. You got to change your clothes. You got to get something to eat. You are not watching television. You got to get over to the new house, or if you're at the house you're in, you've got to start working. You can work about 2 hours. It is now somewhere between 9 and 10 at night. And by the way, you've got to now go get your bath, get all that crap washed off you, put your tools away. You're only going to get 2 hours work a night. 3 if you really press it. And you know what? This job's going to take you a lot longer than you think. If you're not in a rush and you say, 1, I'm retired, which means now you can work 5 hours a day, but you ain't going to do 8. Trust me, I don't do 8. It's going to take you a while to do it, but you can be proud that you did it and you did it right. Last one, very seriously, folks. And I'm serious when I say that if you're lucky, you can put in 5 hours. Yesterday, I put in about 5 hours. I was climbing under the house because I have a steel frame in the backyard that I've got lights strung in. And I decided, well, gee, I want to be able to turn that on and off with a light switch. It's plugged into an outside receptacle. Well, I had to cut in a new box, take the box out, add one, shove it in, bring the conduit back up into it, go down and find out, let's see, that's this circuit, the outside circuit's here, cut this one, put in a box, run a conduit over here, cut this one, put in a box, get that together, run my wires over and up so that, yes, now it's controlled by a switch. Hey, works beautifully. By the way, between getting the switch box cut in to start with, that was about 2 hours, including cleaning up the mess. And then the 5 hours spent yesterday climbing under the house. That's why those zip-up white suits are beautiful. Yeah, I got it done. Hey, it only took me 7 hours. Expert job, folks. By the way, I had a beard. I didn't care whether I went to bed or not last night. So if this presentation is lacking anything, because I didn't practice like I was supposed to, I had a beard. I went to bed. Can you bend a number 10 edge of G with a pair of needle nose pliers? I cannot. There's something right there. Going back to the types of conduit. If you use Romex or armored cable, and let's zip back to those. Oh, it was here somewhere. I don't know it was. Yeah, right there. You're talking solid wire. So like Ruth says, can you bend a pair of bend a number 10 with a pair of needle nose? No, I can't. I wouldn't want to risk breaking my needle nose on that. I use my lineman pliers. By the way, you can get them 7, 8, 9 inch. Buy the 9 inch. The Klein 9NE Klein or Channel Lock. I think Channel Lock bought out Klein nowadays. But yeah, you can buy those at Home Depot. You want the biggest of the lineman pliers. It makes a difference. Yes, you can bend number 10 with that. What if you're pulling? Use stranded wire. Every electrical contractor in this city seems to think that God intended man to use solid wire. And I'm convinced if God had not intended for man to use stranded wire, he would not have invented stranded wire. Now, terminating it around the receptacles gets a little tricky. You need your strippers, ratchet snap strippers, twist the end, and then wrap it around the screw, and you still have a wire springing out. When I went to pull out the switch from when I'd done it 20 years ago, the one I told you about, I had put in a new one beside it. I pulled the old one out and I started pulling, and I looked, and here was the screw. It's a 3-way switch, and one of the screws, one little fine, just number 22 size strand was sticking out. And I was within 1/32 of an inch of touching the side of the metal box. Yeah, you got to watch out for those. By using stranded wire, yes, I can bend number 10 with my Kleins, twist it in a knot. It really makes a difference. So that is one of the considerations. Yes, I can share my slides. They're pretty heavy, so I'll have to drop box them to you. Oops. Do you have? Oh, that was the last slide. Okay. As far as I have no mic or camera on the WebEx call. Let's see who's writing this. From David. I would like to extend. Let me pull this up so I can read it. I would like to extend existing receptacle is what you mean. He said wiring outlet to a new twist lock type receptacle in the ceiling of my garage and make a drop cord with twist lock plug at one end, one box at the other. The drop cord will hang above the workbench in the middle of the garage as a way to bring 120 volt AC power tools in the bench. Are there any code issues to consider? GFCI needed. Not necessarily GFCI, and I'll tell you what, I would put the GFCI in the quad box. The other thing is you're going to need on this cord, you're going to need SO cord. I would use number 12 SO cord. You're going to need CGB with a basket. Now, what cord grip box, that's what CGB stands for. And then it has this basket, looks like a Chinese handcuff. Sorry, Kai. But anyway, what it does, it grips the wire, and you're going to need one up at the box coming out of your twist lock, and the other one on your bench. The other thing to do, yeah, I would just, and I think what you want to do is be able to get that out of your way when you want to move the bench, so that, yes, you don't have this box hanging down and hit people in the head. There is that. The other is go ahead and spring the money, buy one of those retracting reels, and then you can mount it on the ceiling. You can pull the electric down, plug it in. Yes, Ruth says use the cord reel. Kellum's grip. Yeah, thank you, Ruth. Kellum is a brand name. But what you're wanting is a CGB basket on both ends. So you want to twist lock with a CGB or go ahead and wire it in the ceiling. But the best thing is get a cord reel, do it right. So I'm getting choked up about this, so I need another cup of coffee. So go ahead, Kai. Any other questions? Let me unshare,
Well,
unless somebody wants me to stay sharing.
looks like you answered most of them, except I think I saw one. You see,
As far as I'm concerned, everyone can unmute and start shouting questions.
The request to speak.
Yeah, Rick. Now, what I'm going to ask you is start off with, this is Rich, and then go ahead and give me your question.
This is Rich Painter in the Pikes Peak section, Colorado Springs area. The Black Forest fire took our home away and we had a new one rebuilt. I struggled a lot with the contractor because my wife is seriously disabled. And one of the things that became a real sore point, and I had a long conversations with the regional inspection people about this. One of our important egress options for emergency is to go out the overhead door with a garage door opener on it. It's something she could operate and get out with. Yet the regional building required the outlet that plugged into in the ceiling to be on GCFI. And what we have further is we have some of the driest climate in the country right here. So we don't have moisture issues. But these damn GCFIs are tripping all the time. And so here we have a life hazard situation that by putting in a GCFI on that thing creates a hazard for us. And I said, what happens if I change that out? What's your opinion on that?
Well, two things. Number one, once he's gone, he's giving you a certificate of occupancy, swap the damn thing out. Number two, you actually have a more serious problem. And I got this from my floodplain studies. What happens to her if the power is out and that damn door doesn't open?
Well, that's one of many. We have, I've designed the floor and all the external exits to be wheelchair with extreme low profile thresholds that she can get out. There's a side door on the garage, but if there's no power, sure, she can't do that. But it's easier for her to hit the garage door opener and zoom out the garage door without having to even open the other doors. Yeah, so I have 1, 2, 3, 4 egress doors in addition to the garage and its egress doors. So yeah, that's been taken into consideration.
So you're saying this is just for convenience? Yeah.
Well, you never know what door you're forced to go out.
No, Rick, it's just for convenience. It's not emergency exit. Therefore, you cannot argue this is a life situation because you've already got your life X. See, that's what my point is. That if you said, I can't have a GFCI because it might trip and this is a life safety issue, the next question is, what do you do if the power goes out completely? So in other words, that door cannot be considered life safety. So they're not going to buy that. Now, if it's just convenience and you're recognizing that's what it is, but you're having trouble with the GFCIs, the other thing is, instead of a GFCI receptacle, use a GFCI circuit breaker and have the panel accessible so that she can reset it.
Yeah, that won't work. The panel's way too high, so she wouldn't be able to reach it.
And it doesn't there.
Yeah.
There's something wrong there because the panel should not be. If she's in a wheelchair, that panel should, if I'm sitting right here, I don't know if you can see me, but I should be able to reach all the circuit breakers with the wave of my hand.
Yeah, tell the contractors that. I couldn't convince them.
Yeah, well, that's where the golden rule comes in. You have the gold, you make the rules. Now,
Well, that's a nice thing to say. I laid down a lot of law up front in the contract and it wasn't abided by. So, you just sometimes you're the tail trying to wag the dog regardless of who's paying the bill.
and trust me, I've been through it myself. One of the problems, folks, with electricians, and it's not just electricians, it's with construction workers. Quote, boy, I've been doing this since before you were born. It turned out he's actually younger than you are. And I know how to do this and you don't. And by the way, they don't know how to do it. That is an ongoing argument. I had an inspector arguing with me one time, and he said, well, maybe if, yes, I'm a master electrician. Well, maybe if you were an engineer, you would know about this. Actually, I am an engineer. Would you like to see my license? And that stopped that argument. But I happen to have that double trump card. In your case, he's going to say, well, yes, you're an engineer, but you only know the theoretical. You don't know the practical. They're going to give you every BS answer in the book. I think Ruth puts up with that all the time. By the way, Ruth is the chair of our I Square chapter, of which I'm a member. That's what my emblem is here. But she deals with that regularly. Norman, you have a question.
Yeah, it's an observation, not 100% germane to your particular subject, but an observation is Zoom meetings are not great, but I can participate in more IEEE meetings by Zoom than I can normally. Like we have someone coming in from Colorado. An option to have is, even when you get back to normal life, is to participate in person or have Zoom an option for remote participation. We get more attendance at meetings.
Quite honestly, Norman, we discussed that at our Chapcom meeting last week. And part of our problem is, if we have it by WebEx or Zoom, what's the chance that everyone will show up and we can't cover the cost of the meeting place because we need people to come and order food in order to justify getting the meeting hall? If we can't, so we're kind of forcing them to be there. And so do we say, well, gee, unless you prove you live 50 miles away, we're not going to let you come in by WebEx or Zoom? I don't know. So yes, we are honestly working on this, because you're an example right here. We've got, what, Kansas and two from Colorado. No, wow. So yeah, glad to have y'all. Glad we can reach out. I attended my lodge meeting the other day, sitting right here in my chair, and it's up in Cincinnati. So yes, but there are limitations of what we can do. We are honestly exploring it and looking at it and giving serious consideration. Any other one thing I want to tell y'all about dealing with the utility, and this is very important. A buddy of mine, fellow electrician, moved down here from Cleveland. And he and his wife bought a piece of property, had an old house on it. They tore it down to the foundation and rebuilt it from that up to what they wanted, only a mile from me here. And he decided that what he wanted was this square D meter panel combination, the meter base and the panel together. And I said, Dale, you better go check with the utility on that. I'm not worried about it. This meets the National Electrical Code. Dale, you need to check with the utility. Folks, I told him must have been 3 times, you need to check with Austin Energy. Well, after paying good money for this damn thing, he found out that, one, they would not accept it. Well, the reason he went to that, I'm sorry, I'll back up. On the north side of his house, he had the meter, and they gave him a green tag. They said, this is good. Well, it turns out that's the side that faced the street. He wanted the panel board, the main disconnect and all that, on the south side. And he just run the conduit over and up. Well, up in Ohio, yes, we did that all the time. We could run it up to 10 feet unless it was outside the building. If it's either physically outside or encased in concrete, it's considered outside the building. So he said, it's outside the building, it doesn't matter. That's not the way Austin Energy sees it. They want the disconnect right beside the meter. And he didn't want that. So he wanted to put it on the other side. So he got this combination. Don't remember how many $100s it cost him. Special order, meter base and panel. And Austin Energy said, no, that's not part of our approved equipment. You have to use regulation meter base. You can submit this to our engineering department. They will review it and should be able to give you an answer in about a month or so. He couldn't wait that long. And a month or so means minimum 2 months. So he went ahead and he went to Home Depot and he bought a meter base and he put the damn thing in, grumbling all the way. Then he found out you don't go to Home Depot to get the meter base. Yes, what he bought was exactly like the one Austin Energy, actually it was slightly smaller than the one Austin Energy approves. He had to go to the electrical supply house and buy one that's stamped AE on the inside, because that's the ones that Austin Energy has pre-approved. He has a total of 3 meter bases, and he had to buy the 4th one just to get it in. What's the rule here? What was that second slide I had? Talk to the utility wherever you are. Please talk to the utility. Do not try to say, I know all about electricity and I know how to do it according to the NEC. That's the minimum. You got to meet their standards. Richard, you have a question.
Yes, in garages, the receptacles are higher than normal. What is the rule on that?
I don't think there is a rule, except that usually if you put them between 3 and 5 feet, it's where a person can stand up and plug in, not having to reach up like this, unless he's a little short person. You can put them down lower, but normally they're put up higher because you're not sitting at a chair. You're not putting on a desk with a stand like we have right here. No, you're walking up to stuff. You have a workbench. That's what the rule is. Not a written rule. It's just some people think a receptacle has to be 6 inches above the floor. No, it does not have to be. It's just that's common practice.
This is Don House.
Yeah, Don?
The other thing about garages, and this is rather interesting, if you have a detached garage, a whole bunch of different rules now apply, because it's now an outside structure. Because I went through this, and so all of the outlets that are in the ceiling, there was no problem, but all of the outlets in the wall must be GFCI protected.
Yes.
So it's a case with, depending on if your garage is attached to your house or not, there are different rules that apply. And your story about the guy with the meter and the connection, my other house is a 1910 house. When I had it rewired, I told the electrical people, here's what I want. And they looked at me like I had sprouted horns. And so here comes the thing from the utility company, who I worked for, down through the meter into a 200 amp fused disconnect switch. And then after that disconnect switch, you pretty much do anything you want. You want to run the conduit halfway around your house? Not a problem. You want to go down, which is not what I did, but I went down and then punched through the foundation. And then it was a 7.5 foot horizontal run in the crawl space, so that when you went down the stairs, the breaker panel was right there next to the stairs when you got down to the basement. And I told the electrical contractor, here's what I'm doing. Here's why it has to be done this way. This is how you're going to do it. They looked at me and said, okay. And then when the people were hooking up everything from my employer, they saw that fused disconnect switch on the back of the house, and the guy said, what are you putting in the house? So I had to explain to him what it was and who I worked for, and he kind of said, well, okay. And that was the end of that conversation. But
Don, you brought up a very good point, and that is the electricians, when faced with something unusual, usually the first words you hear are either I've never seen that before or we never done it that way. Or the third one, we don't do it that way. I don't really give a damn the way you don't do it. If I'm paying you, the contractor, you're going to do it my way. The utility is a different story. Then we go back to the golden rule. They have the golden electricity. They make the rules. But Yes, and that was Dale's problem. He didn't want that disconnect right below the meter. He wanted it on the other side of the house. Again, we do that in Ohio. This ain't Ohio.
Yeah.
Okay. Questions?
Well, we're about 1 minute, so this may be the last
Okay.
question.
Well, folks, my email address is jmercier@IEEE.org. So jmercier@IEEE.org. Send me questions, and when I sober up, I'll try to answer them. Hey, I'm retired. I retired from the state. I'm retired as an electrician. All I do is bum around, drink beer, and do 2 hours of work on the house a day.
Well, you did a good job, James.
Thank you, Kai.
Yeah, you can always find him in the CTS website, or go back to the V2 address that you saw this announcement. So you can find him, or you can write to me. You want to talk to James. Okay, so thank you for everybody's attending, and have a good evening. And thank you again, James. And you're going to send us the slides. We can post it in our website, James.
I'll get those over to you, Kai.
Okay, great, yeah. So I'm recording this, so depends how thing it goes, and maybe I make it a shorter version so that we can put in a website somewhere. Okay, I have a
Okay.
recording.
Well,
Thanks,
look,
James.
I got one question before you go, Kai.
Yes.
I thought I was supposed to get a coffee cup or something for this presentation.
Oh, I can email that to you.
And for those of you who don't know, we got section coffee cups, all right. I've got 7 cases of them here at my house.
Yes.
Kai, you need to give him another case.
Yeah. Right. Yeah.
Ain't
So
gonna
I'll
happen.
buy your
Good.
beer next time we meet each other.
All
For the
right.
folks from out state, and thank you for attending.
Good night, Kai.
Yeah, good night. Good night. Bye, everybody.
All right, thank you.